Hi, and welcome to today's math lesson on surface area of cylinders. Our do now reads the volume of the cylinder below is 276.95 cubic inches. What is the height of the cylinder in inches round to the nearest tenth? So we have to work backwards since we're given the volume and we have to find the height. But we are given the radius of this cylinder. So our volume formula for a cylinder is V is equal to base area times height. And so our base shape is this circle, and the area formula for a circle is pi radius square. So now we have V is equal to pi radius square times height. Now we can plug in what our volume is. So we have 276.95 is equal to, for pi, we're going to use the number 3.14. Our radius is 3.5. And we have to square that. And since we don't know our height, we're just going to keep it as h for now. So our next thing that we can do is we can multiply 3.14 times 3.5 squared, which is the same thing as 3.5 times 3.5. So we have 276.95 is equal to 38.465 h. And to figure out the value of h, or to move the 38.465 to the other side, we're going to divide both sides by 38.465. So when I divide 276.95 divided by 38.465 and round it to the nearest tenth, I get 7.2. And our unit of measurement in this problem is inches. 38.465 divided by itself is going to be 1, so we can cross that out. So we've reached our answer, and that is h is equal to 7.2 inches. Our TEK for today is 8.7b. Our lesson target is that scholars will find the lateral and total surface area for cylinders, and our DOL is given 4 problems. Scholars will find the lateral and total surface area for cylinders with 100% accuracy. Some vocab words include area, base, circumference, cylinder, diameter, face, height, length, perimeter, prism, radius, rectangular prism, triangular prism, and width. So the new vocab word for us today is the word circumference. So circumference is the distance around a circle. So we've been working with area, which is the inside measure of a circle, but the circumference is the outside measure of a circle. And so the circumference formula is C is equal to pi times diameter. Or if we wanted to do it in terms of the radius, it would be C is equal to 2 pi r. And these two equations are equivalent. They're equal to each other because 2 times the radius is the diameter. So imagine unrolling the container's lateral surface to form a rectangle. So basically we're making the net of a cylinder. So imagine a tin can and you cut the top off and then you make a slash through the can and then you unroll it, and that's what this is right here. It's the net of the cylinder. So as you can see, the radius is labeled, the height is labeled, as well as the circumference. So to answer the question, which dimension of the cylinder matches the rectangle's length? The rectangle's length is going to be the circumference of the circle, because when we unroll that rectangle, it used to be rolled around the circle, right? So we're going to say that it's the circumference. Then for which dimension of the cylinder matches the rectangle's height, it's just going to be the height of the cylinder. So getting into the equations and breaking them down just so we can better understand them, the lateral surface area equation for a cylinder is 2 times pi times radius times height. So that's basically the circumference of the circle times the height of the circle. Because remember that the lateral surface area does not include the area of the circle, since the two circles, are the bases. So lateral surface area, again, does not include the area of the basis of a shape. So basically, we're finding the area of the rectangle and then the circumference of the circle. Because one side of the rectangle is the height of the shape, that's why we have h, and because the other side is equivalent or equal to the circumference of the circle, that's why we have our 2 times pi times r. Then for the total surface area equation, we have that 2 times pi times r times h, but then we also have to add the area of the two circles. And so the area formula for a circle is pi radius squared, and since we have two circles, we're multiplying it by 2. So that explains our total surface area formula, since it's the area of the two circles plus the area of the rectangle. This first I do reads, find the lateral and total surface area of the cylinder to the nearest tenth. And we have to use 3.14 for pi. So our lateral surface area formula is LSA is equal to 2 times pi times r times height. Then we're going to plug in the numbers that we know. So we're using 3.14 for pi, so we have 2 times 3.14. The radius is given in this problem, which is 4. The height is given, which is 7. So now all we have to do is multiply it out on a calculator. So we have 2 times 3.14 times 4 times 7, and that is 175.84. And our unit of measurement in this problem is feet. And because we're finding the surface area, it's feet squared, or feet raised to the power of 2. Now on to finding our total surface area. So our total surface area formula is TSA is equal to 2 times pi radius squared plus the LSA, which is 2 pi r h. So we're going to use the number 3.14 for pi, so we have 2 times 3.14, and then our radius is 4, so we have 4 raised to the power of 2, or 4 squared, plus this 175.84. So when we multiply 2 times 3.14 times 4 times 4, we get 100.84. And then we still have to add the 175.84. So once we add 100.84 plus 175.84, we get 276.32. Because we have to round to the nearest tenth, I'm going to circle the number that's in the 10th place, which is the 3. I'm going to underline the number that's to the right of that. So 4 or less, we're going to let the 3 rest. So our answer is going to be 276.3 feet squared. And that is our total surface area of this cylinder. This next I do problem is a word problem. A can is 11 inches high and has a diameter of 9 inches. How many square inches of paper are needed for the label? How many square inches of metal are needed to make the entire can? Round your answer to the nearest whole number. Use 3.14 for pi. So if we think about it, the label only goes around the rectangular part of the cylinder. And so that makes the label the lateral surface area versus the metal is going to be the total surface area because the metal includes the 2 circles or the 2 bases. So we're going to start with the lateral surface area since the total surface area uses our lateral surface area. And so our LSA is equal to 2 pi r times height. So then next we're going to plug in the numbers. So we have 3.14 for pi. In this problem, we have to figure out what our radius is because we're given our diameter. So remember that the diameter is twice as long as the radius, or we can think about the radius being half as long or half as big as the diameter. So if our diameter is 9 inches, our radius is going to be half of 9, which is 4.5 inches. So our radius is 4.5. And then the height of the can is 11. So once I multiply 2 times 3.14 times 4.5 times 11, I get 310.86. And because I have to round to the nearest whole number, I'm going to circle my number in my ones place, which is a 0, underline the number to the right of it, which is the 8. 5 or more, we let the 0 soar, so the 0 becomes a 1. So our answer is going to be 311 inches squared. Since we're rounding to the nearest whole number for this problem. Then moving on to our total surface area, we have TSA is equal to 2 pi radius square plus 2 pi radius height, or h. So for pi, we're going to use 3.14. Our radius, again, is 4.5, so we're going to have to square that or multiply it by itself. So we're doing 4.5 times 4.5. And then we're going to have to add the 311. When we multiply out 2 times 3.14 times 4.5 squared, we get 127.17. And then if we add the 311, we get 438.17. and we still have to round to the nearest whole number. So again, I'm going to circle our number in the ones place, which is 8, underline our number to the right of that, which is 1. So 4 or less, we let the 8 rest. So our answer is going to be 438 inches squared. There's several you-do problems. And then, of course, the 4-question Google Form DOL. Thank you so much for following along in today's math lesson, and see you in the next math video.